Good morning. Today we're going to be covering 2.4, which is formulas and percents. So when we're done with our homework, we should be able to solve a formula for a variable, express a percent as a decimal, express a decimal as a percent, use the percent formula, and most importantly, solve applied problems involving percent change. So why don't you guys go ahead and start your warm-up, pause the movie, warm up, get all ready for math, and then I'll check in with you in a moment. Notice that the variable is on the right side this time. So what we want to do is we want to isolate this variable. And do you guys see that if we were to either divide both sides by 0.25 or multiply by 1 over 0.25, but you have to balance it out by doing that the same on both sides of the equation. So here completely divides out, and over here, just in case you forgot, let's do a little side work. This is saying 4 divided by 0.25. So you have your 0.25 as your divisor, and then you have a 4. Now it's not going to change the value if you add zeros after the decimal place and the 4 there. So recall that you move this over twice, the decimal of the divisor over until it's a whole number, and then you're going to move this over the same amount, and the new decimal placement will go there. So there's 125 and 40. When we subtract, we will get 15. Bringing the 0 down, we have 150, and there's 6 25s in 150. When we subtract, we get a 0 remainder. So what we have found is that 16 is equal to B, and of course if 16 is equal to B, then B must be equal to 16. So we'll put our solution here. And of course, as the last step, what you should be doing is you should be double checking to make sure that this does indeed work. And if you checked in the original equation and you multiplied 16 by 0.25, you would end up getting 4, so you have an identity. But I will leave the checks to you guys to do. All right, here we go. In a similar way, we will be multiplying by 126 in order to isolate the variable. Again, some side work. 1.3 is the dividend, 26 is the divisor. Adding a 0 here, we're going to end up with, we'll put our decimal here. So let's see, let's try, we know that there's 0 26s in 13, so let's try 5. So we'll get, oh, that works out fine, check that out. So what we have found out is that 5 hundredths is equal to P, so P is equal to 5 hundredths. All right, how'd you guys do? All warmed up? Good. Let's go ahead and do our next bit of business. All right, solving a formula for one of its variables. Solving a formula for a variable means rewriting the formula so that the variable is isolated. On one side of the equation. To solve a formula for one of its variables, you treat that variable as if it were the only variable in the equation. Now, perimeter. The perimeter of a two-dimensional figure is the sum of the lengths of its sides. Perimeter is measured in linear units, such as feet, inches, meters, or miles. There's many, many more. Oops. Sorry about that. Okay. All right, now you've worked with rectangles many times in your math lives. The perimeter, which is denoted by P, of a rectangle with length L, so we can call this length L, and width W, is given by the formula. Perimeter is, so how many W's do we have? If you look over here, do you see the thing about a rectangle is opposite sides are equal. So we have two W's and we have two L's. So that's exactly what the formula is. Now, if you recall, and using the distributive law backwards, we could also write this as 2 times the sum of L plus W. Either way I'm okay with, so you decide which formula you prefer, or you can just remember it's the sum of all the sides. A square unit is, you guessed it, a square, each of whose sides is 1 unit in length. The area of a two-dimensional figure is the number of square units it takes to fill the interior of the figure. So I copied this one figure. Let's check it out. So it looks like this. A little smaller. Okay. So if you notice inside, I don't know if you notice inside the figure, but the there's a T that's outlined. And you know, this is a shape where we can find the area. So notice that the area is going to be comprised of how many of these squares are showing up in the figure. So do you see if we actually could count? You see there's 1 square, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares in the T. So this is 10 square units is the area of the T. Okay, so you know, when you're doing different measurements in real life, if you're buying carpet or flooring, the carpet covers, you know, is the surface of the floor, so that's considered in square yards or square feet. And when you're buying baseboard, that's sold in linear units, so it's the length of the baseboard that you buy is how that's measured. So that would be measured in feet, usually. All right, so next up, area of a rectangle. The area A of a rectangle with length L and width W, again, L and W, is given by the formula area equals length times width. Okay, so let's take a look at this next step. We're going to solve the following formulas for the specified variable. So in this case, we're looking to isolate the t. So why don't you go ahead and pause the movie and see if you can figure out this problem and see how you do. Ready? On your mark, get set, go! All right, here we go. I'm gonna rewrite the problem so I have room to work. So d is equal to r times t. We want to get t all by itself. So do you see, if we were to multiply both sides by 1 over r, then the r's would divide out, and we would have distance over rate is equal to time. So of course that means that time is equal to distance divided by rate. And that's the result. Now we're not going to be putting this one in roster notation because we've just rewritten this formula and isolated a different variable. So it's not a conditional solution to an equation. All right, this one was a bit more of a bear. This one, we have to use the distributive law backwards. So if we take P, and I know it's going to look a little strange, but I'm going to rewrite this as C times 1 plus C times M. Okay. You guys take a look at that. Do you agree? It's the same as it's equivalent to what was above. Now, if you remember, the C is showing up twice, right? And then we have this other one here and this guy here. So using the distributive law backwards, I can write it as C times this sum of 1 and M. So this is the yellow, this is our green, and this guy is our blue. And so just take a moment to sort of mentally distribute that C. Do you see that we get the same result? Okay, good. So now we need to isolate. We need to isolate the C. So if we multiply both sides over 1 plus M. This, believe it or not, this whole 1 plus M divides out. And at the end of the day, we will have P divided by 1 plus M is equal to C. So of course C is equal to P over 1 plus M. That's our end result. How'd you do? That's kind of like a, isolate the formula for the specified variable problem that's on steroids. I mean, that's a hard one. If you got that one, you should be proud of yourself. All right. Next step. So here we go. Now we're getting into some thinker problems. So we've got a rectangle. So you know what? What the heck? Let's make a picture of a rectangle. It's got an area of 15 square feet and a width of 3 feet. Okay, so we'll just make one. We don't know the exact scale of this rectangle, so we'll just make a rectangle here. And then we do know that the width is 3 feet. So remember, this is W is equal to 3. We don't know what L is, but we also know that the area inside is 15 square feet. And of course, this is in feet. So, find the length. What have we been given? Can we go straight to the perimeter? What do you think? You got it. We have the area, right? So don't we know an area formula for a rectangle? Don't we know that area is length times width? And you see that the area was 15. So we can actually plug that in for A. The width is over here. It's 3. So we have two values that we know and one that we don't know. So we're going to be able to actually plug these in. That was our width. And here's our area. And we're going to be plugging these in and isolating L. So how do I isolate L? Good. We're going to divide both sides by 3, or equivalently, we'd be multiplying by a third. And so, do you see that 5 equals L? So L is equal to 5, what? Bananas? Puppies? No, right? Feet. The length is 5 feet. Okay, we now know that the length is 5 feet. Right? So do we have enough information to find the perimeter? Now, you have to be very careful. What I have found in the past is that people want to only write this part, the 2L plus the 2W. You have to say P equals that, just like we said A equals length times width. That gives us an equation, and so once you have an equation, you can put in known values of variables, and then you can solve for the unknown variable. So in this case, what's the unknown variable? Good, the perimeter, P, is the unknown variable, because we found L over here. Whoops, sorry. L is 5. So here we go. The perimeter is equal to 2 times 5 plus, what was that width again? Good, we'll be reusing it. The width was 3, remember? And we found the length, L, to be 5. So now we got the perimeter is 10 plus 6. The perimeter is 16. And what kind of units is that in? Good, linear units, so 16 feet. Okay. Next up are basics of percents. Basics of percents. Percents are the result of expressing numbers as part of 100. The word percent literally means per 100. So N percent means N per 100. So this symbol here, this percent symbol, is the fraction bar, per, and the 100 denominator. You could also write this as N times 1 over 100. So again, that percent would be 1 over 100. So steps for expressing a percent is a decimal number. So if you've been given a percent and you're moving to a decimal, you're going to be dividing by 100. So what happens when you to the decimal place when you divide by 100? You move it, good, 2 places to the left. Awesome. So let's write that in. Move the decimal point 2 places to the left. And then remove that percent sign because nothing in math is free. So if you're moving the decimal point 2 places to the left, you have to take away that percent sign. All right, here we go. 9.5%, remember, is equal to 9.5 times 1 over 100. You can literally replace the percentage with this guy. So then this is going to be, dividing by 100 will move that 2 times. So we will have 0.0912, yep, 5. So that comes to 95 thousandths. Okay, go ahead and give number 2 a shot and see how you do. Okay, this is going to give us 235 times 1 over 100. Again, changing that percentage sign, these are equivalent. So we will end up with a result. Remember, there's this kind of invisible implied decimal point there at the end of a whole number. So moving the decimal 2 places to the left, we'll end up with 2 and 35 hundredths, 2.35. How we doing? You hanging in there? All right. Well, we're more than halfway done on our lesson. So, steps for expressing a decimal number is a percentage. So now we're going the other way. So in this case, we're literally going to be multiplying by 100%. I mean, 1 equals 100%. So when you're multiplying by 100, you move the decimal point 2 places to the the right. And then you're going to attach a percent sign. That's how you pay for that. So here, we're going to multiply this by 100%, which is just multiplying by 1. Okay. And we will get a result of 175%. You try the next one and see how you do. Okay, multiply by 100%, and we end up with 1%. How'd you do? All right, cool. A formula involving percent. Now, my main concern is that you can solve applied problems that involve percentages. So our author, gives specific formulas. Some people are much more comfortable solving using proportions. So whatever works for you, I'll show you a couple different methods, but whatever works for you is what I want you to use. All right? So a formula involving percent. Percents are useful in comparing two numbers. To compare the number A to the number B using a percent P, the following formula is used. So, A equals P times B. A is just A, right? What does equals mean in math? Good, is. P means P%. What is a times in words in mathese? Good, of. And then B is just B. Now, a couple alternate ways to do this. Part is to whole as percent. I'm used to writing it as in, okay, is to 100. Another way that people learn is over of equals in over 100. So here we go. What is 12% of 50? So if you follow the equation the author gives exactly, do we know what A is? No. It says what, right? Is. A is. So we'll just say A is. 12% of 50. So 12% times 50. So the B is the 50 in this case. Now in order to compute this, we need to rewrite 12% as a decimal. So do you see we'll get 0.12 times 50. And then when we do the computation, we will get A is equal to 6. So 6 is 12% of 50. Now, let's take a look at the second problem. 6 is 30% of what? So if we use again the equation, sorry for that message. If we use the current equation, here's what we will say. A is 6. Is means what in mathies? Good, equals. And 30% of means what in math? Good, times. And then now we don't know the B. So we will have 6 is equal to 0.30 times B. And then isolating the B, we have to divide both sides by 0.30, and we will get 20 is equal to B, because these divide out to be 1. And when you divide 6 by 0.30, you get 20. So if 20 is equal to B, then B must equal to 20, and we're all done. Now, number 3, I'm going to show you a little bit differently. If you like the equation, you know, you would set it up like this. You would set it up as 200 equals P% times 20. Okay? I'm going to show you an alternate way. If you do part, which is 200, over whole, which is 20, or you can say is over of, and that's equal to n over 100. Now, remember, if you have a proportion, one fraction equal to another, you can cross multiply. So you're going to get 200 times 100 is equal to 20 times n. And then if you were to multiply both sides by 1 over 20, which is equivalent, remember, to dividing by 20. I purposely didn't combine these because I saw that 20 goes into itself once. 20 is going to go into 200 10 times. So we will end up with 10 times 100 is going to be a 1 with 3 zeros. These 20s divided out. So believe it or not, we will end up with N is equal to 1,000%. Okay. Now on the other one, if you had done this one, so remember we had decided to do this using a proportion. So if you had done the other one, you would have gotten a similar result. Or the same result, actually. Okay. Moving right along. Now again, the author gives you a specific formula for percent increase and percent decrease, which will give you these formulas. There's always, some alternate sort of common sense ways one can move through, in order to solve these things. So I'm going to be showing you a variety of ways. Again, you have the same formula, but in this case, what A is standing for is the increase. Okay. P is standing for, what percent. And B is standing for the original amount. But you have to be careful because this is only going to give you the percent increase. So oftentimes, in application problems, they want you to use the percent increase to tell you the new price, for example. If something was increased, then what is the new price? So you're going to have to still use common sense to figure out or number sense to figure out what your end result should be about what kind of number. All right, percent decrease, again, you have A equals P times B, but in this case, this is the decrease. Again, what percent? And B is the original amount. Okay, so let's look at some applications here. This application is going to be quite useful to you. Oftentimes you want to figure out what score you need to get on either your last exam or your final to get you a certain percentage in the class. So, the average or mean A of 4 exam grades, X, Y, Z, and W, is given by this formula. You add up your exam grades, divide by 4, assuming they're equally weighted. So here we'll practice by solving the formula for W. So let's rewrite the general formula. How do I isolate W? Good. I would need to multiply both sides by 4 in order to divide out that 4 here, or get rid of that 4. So now I have 4A is equal to X plus Y plus Z plus W. So do you see that if I were to subtract an X, subtract a Y, and subtract a Z, so I'm subtracting an algebraic expression from each side in order to isolate W. So on the left I will have 4 A's, and I had subtracted an X, subtracted a Y, and subtracted a Z. And then do you see I'll end up with 0 plus 0 plus 0 plus W? And that, of course, gives us 4A's minus X minus Y minus Z is equal to W. Now, if that is true, then W must equal 4A's minus X minus Y minus Z. And we have successfully isolated this formula for W. right, next up, we're going to use this formula. W equals 4a minus x minus y minus z. We're going to use that to solve the problem. What we are going to do is we are just going to plug in the numbers in front of the percentages, and then we will add a percentage in our answer, okay, in order to keep from getting confused. So we are looking for the fourth exam W to have an average of 80%. Let's figure out where the heck this 80 is supposed to go. Good. 80 is the average that we want. So this 80 is 80% goes in for the A. Now, minus. So the first exam score was a 76, next one was a 78, and the one after that was a 79. So I'm plugging those in for X, Y, and Z. All right, so go ahead and simplify that. Let's see, this is what I got. 4 times 80 is 32 with a 0 at the end. Now these are all negatives, so when I added them up and assigned the negative to it, I got 233. So W is 87. Let's answer, it was a word problem, let's answer this in words. I must get an 87% on the fourth, exam to have an average of 80%. I'm just answering the question they asked. That last line of the problem usually tells you how to put your answer in words. Okay, last page of the lesson. Woohoo! A charity has raised $225,000 with a goal of raising $500,000. What percent of the goal has been raised? Okay, let's look at this just as an estimate, number sense wise. 250,000 is exactly half of 500,000. Would you agree? So they're almost halfway there. So in percent land, what is half? Good, 50 out of 100, which is 50%. So let's take a look at this. So I'm going to go ahead and set this one up using a proportion. So they've already raised $225,000. The goal is to raise $500,000. So 225,000 is the part and 500,000 is the whole. That is equivalent to, well, we don't know the percentage, so we'll just say n over 100. So now we have a proportion. We can cross multiply. So we will end up with 225,000 times 100 is equal to 500,000 times n. Now, if I multiply both sides by 1 over 500,000, do you see that I can divide out 100 here, which will divide out part of this quantity, okay? And then the 500,000 completely goes away over here. So, let's see what we ended up with. We ended up with 225,000 over 5,000 is equal to n. So we still need to go a little ways to simplify. So here, do you see at the end of the day, we will get 45 is equal to n. So let's answer the question. 45% of the goal has been reached. And if you think about it, that is near our estimate. We figured it'd be a little less than 50%, and that's what we got. There we go. All right, next step. Suppose that the local sales tax rate is 7% and you buy a graphing calculator for $96. How much tax is due? How much tax is due? So basically, what do you do when you're finding tax rate? Right? I mean, do you see that the tax is going to equal the price times the tax rate? So let's just call tax T. What was the price? Good, $96. And the tax rate was 7%. So the tax will be 96 times 0.07, changing that 7% into a percentage. And let's see what you guys got for that one. I ended up getting 6.72. So $6.72 of tax is due. So what will the calculator cost? Well, won't it be the price plus the tax would be the total price? So the price, remember, was 96. The tax was 672. So when we add that together, I believe we get $102.72. The total cost, and maybe we should say total cost here to the consumer instead of total price. So the total cost is $102.72. Okay, I'm going to warn you ahead of time This one here is a bit of a bear. All right, it's kind of conceptual in nature. So here we go. If we take a look at this problem, so the price of a color printer is reduced by 30% of its original price. We don't know the original price, okay? When it still doesn't sell, its price is reduced by 20% of the reduced price. The salesperson informs you there's been a total reduction of 50%. Is the salesperson using percentages properly? If not, what is the actual percent reduction from the original price? So what do you think? What do you think? I mean, if they had done 30% of the original, got a new price, then they did 20% of the original and then deducted it from that new price, then we'd have a 50% reduction. But do you see, if they're taking 20% of a lesser price, it's not going to be a full 50% of the original. So let's kind of work this out. If you take a look at, A is equal to P times B. Okay. Now the percent of reductions is going to be what A is. So A is going to be 30% times B. So remember, B is the original price. So this is the amount of reduction, right? So A equal to 0.30B is the percent decrease. But what are you paying? Right? What is the amount? Do you see the new amount, the new price, would be 70% of the original price. So remember, B, I'll just write it alongside here. B is the original price. So, okay, we found the percentage discount, but isn't the new price going to be, the new price is going to be 70% times B. If you took 30% off of B, right, to get the discount, you're paying 70% of B, which of course is 0.70 times B. So now you take a look at it here. You're doing a new discount, okay? So it's a new A. So this new one is going to be some new A. We could call it A2 is equal to 20% times that new price, which we decided was 0.7B, 0.70B. So do you see that we will have this new amount of discount will be 0.20 times 0.70 times B. So let's take a look at what all that means. So if we work that out, this new amount of discount is going to be 0.14 times B. So if you think about that, the adjusted discount, instead of being a full 20% of the original, do you see, is 14% of the original? So this is what we found. 30% plus 14% is equal to 44%. So the actual percent reduction from the original price is 44%. Again, that one, is harder than what you would see on an exam, but just, an interesting little problem there. So that wraps it up for today. Remember, go do your homework, study hard, don't kill any brain cells, and have a great day. Bye.